Non ce la faccio, cioè, non ce la faccio. I'm sorry to tell you that I really can't let Lara speak, introduce the webinar, because I'm the only one I can speak, and I can figure out why the application don't let me do this thing. Okay, but anyway, I will start the same. This webinar because I exit and I enter again, so we are waiting for some participants right now, but they are arriving, so here I am. Okay, so welcome to this webinar. I'm very happy to have you connected here, and today I will speak about sync injectors and our product family that include GigaSync and LightSync. First of all, I would like to show you some slides and talk about it during the presentation. Well, so today I will speak about PoE, grounding, Cambium synchronization, and of course 9.sync injectors. The first topic I would like to explain is PoE in general. I mean, there are a lot of kind of PoE standards. The main standard is the IEEE 802.3, and we have three families. The AF is maximum 15.4 watts, 80, 30 watt, and BT up to 90 watt. This means that each standard has its own power limit. So if you need to power a particular device, you have to figure out which is the correct standard for PoE, because some devices need a lot of power, other need less. And you have to verify which is the right requirement in terms of power that your device need. And moreover, there are a lot of pin out for the PoE. We have 8 wires in Ethernet cable, and we can give power to these cables in a lot of ways, different ways. So for example, the A standards is with is the A, so 1 and 2, the couple 1 and 2 have the positive of the power, and the 3 and 6 the negative. B means 4, 5 with positive, and 7, 8 with negative. And for gigabit, for example, you have to use A plus B. You can use, and it's suggested, really suggested to use A plus B, because the power is shared to all the wires in the Ethernet cable. So 1 and 2 and 4 and 5 for the plus, and 3678 for the minus. Then we have another kind of a PoE system wiring, is the A plus B reverse polarity. In this case, the B is reverted, so the polarity is minus on 4, 5 and plus 2 on 7, 8. And the A standard is like the one described before. In this kind of application, this kind of PoE system is very suitable for every kind of gigabit devices, especially for those one like microwave and Cambium, of course, need this kind of PoE mapping. So you can easily imagine that this very great family of standards have a lot of pros and cons. So, for example, we have active injectors and passive injectors. Active injector are that kind of injector that need a lot kind of CPU, a kind of processor that negotiate with the power device, which is the standard of the power device. And if the device need some particular power, the power supply will give to this device the required power. It works only in high voltage, so 48 or 55, 54 volts, not 24, for example. Before the power supply give power to the power device, it checks if the power device is a standard power device. So if it has a sign, particular sign, only after this validation, the device will acquire the power to start working correctly. This means in the active injectors, we have a lot of protections. For example, for under voltage and for reverse polarity. If I put a reverted polarity on the device, it doesn't matter, no problem at all. So a lot of protection, a lot of pros, but if you want to use passive injectors, you can have a simpler electronic, so it's not necessary to verify all the standards. Just plug the device to the injector and boom, it starts working. Apparently, there are no power limitation. You can power every kind of device with every kind of passive injector. It will work, but you have to consider that the power injector is made to carry on a power, a particular power. So if it's built to power low power devices, small loads like the AF standard or the AT standard, the risk is great, and the risk is to burn all the devices connected to the power injector, the PoE injector. So be very careful about this no power limit, because it's only apparently a no power limit. Okay, another topic is isolation and grounding. Usually we have the tower, we put the tower to ground, we connect the tower to ground, then we add devices on the towers. Some devices need, for example, minus 48 volts. That devices put the ground connected to the positive wire. So you have positive to ground. In other cases, other devices have negative to ground. What happens if you install these devices on the same pole, on the same tower? That you make a short circuit between the positive and the negative of two different devices connected to the same ground connection. So it's very, very easy to make it not working correctly or to burn out sometimes. The enemies of the isolation is, of course, hybrid systems. If you don't have a unique system to power all your devices, or a homogeneous system to power all your devices, the risk is to have these problems with grounding. PoE switches are very good switches, but maybe not. They are not the right answer to power PoE devices in towers, because they have often the minus to ground, or at least they have the same references to ground. So maybe if your devices are connected to in different ways, the switches can be the junction point, and it can cause some very big problems to you. And of course, power stations. Also, power station has the same issues. Usually they are not isolated, or if they are isolated and you connect to two different grounding system, the isolation is not enough, of course. Another thing to think about is the polarity interruption. In case your power system verify that there is a short circuit, for example, on one of your devices, usually the power system interrupts one of the two wires going to the device, so the plus or the minus, one of the two. And which one? We can't know, we don't know. It depends on the power system. Some devices, some power systems interrupts the positive, other interrupts the negative. And it can happen that your device connected to the pole is still working, is still powered, even if the power supply interrupts the wire. Because the other pole, the pole disconnected by the power system, is still there, powered by the ground reference to the other device. So it can be very disruptive, this scenario on a tower with the same grounding system. So be very careful about grounding, and try to imagine all your connection schema, your connection map, because it's very, very important to do this. Let's talk about syncing, because we are introducing the Sync Injector product family. So injection is one of the most important thing we will speak about. We are speaking, of course, about Cambium synchronization of Cambium devices. The first method in synchronization through Ethernet to PoE is the Canopy Sync. It's quite old. It works at 29 volts, and it's like an hiccup, you know, because it interrupts the power every few milliseconds or 9 nanoseconds, and it interrupts the power, just like I show you in the graph, only for pair 4, 5, and 7, 8. In a way, take the power out from your device and then power it again. There is a lot of hiccup in during powering these devices. The device will trigger these rays, these power again the unit and synchronize with this hiccup. Then there is the Cambium Sync, but it's patented and I can't show you how it works, but I can tell you that it works at 48 volts or up to 54 volts in the standard telecom. All the pairs are involved in the sync pulse, so all the 8 wires in your PoE cable, in your Ethernet cable are involved, so it's absolutely only 4 gigabit devices powered by all the wires, and there's no power interruption. It's very clever system, I must confess, and it's very difficult to build up, and the electronics is very difficult to manage, but it's a very useful syncing method. In general, power over Ethernet is now the main system, the main method to power devices such as radio equipment, Wi-Fi access points, cameras, IoT devices, and so on. And equipment are often installed on structures where the risk of faults and short circuit surges are very high. It is very often to have these kind of risks on towers, for example, towers. They require more and more current, high current, like for example, I don't know, Cambium Medusa or microwave radios require a lot of power to stay up, to stay powered. And the problem is that the higher is the current, the higher is the probability to have a fault on the wires. And of course, some devices need sometimes to be rebooted. For example, because there is a software or a firmware block that need to be solved. So maybe sometimes you need to simply make a power cycle, power off and on again. And all these kind of problems listed so far means long services, intervention on site. You have to take your car and go to the tower, and a lot of costs to maintain these services. And of course, your customer will be very disappointed about it. So this is the scenario in which most of the WISPs and system integrator are facing their activity. Moreover, you have a lot of PoE devices, and maybe you have a lot of energetic load requirements. So some devices need low power, some devices need more power. And some devices need 24 volts and some devices need 48 or minus 48. It depends on device. And so many feeders results in a lot of cables going to your cabinet and making like ropes, you know. It's a very messy cabinet, which is the components of a typical installation. We have DC-DC converters. It is required, they are required because to solve the ground problem may be caused by a switch or by a power system that mixed the ground reference. You need converters, isolated converters. So for example, 48 to 48 volts, but with isolation, or 48 to 24 volts with isolation. Why with isolation? To solve the ground problem. Then we need surge protector, of course, because suddenly can arrive an overvoltage or an overcurrent that block your entire system. And it's great to have it. Then, if you are powering Cambium old 450, for example, you need, and you want to synchronize these devices, you may want to synchronize it with a power system like Cambium CMM4. It works on 29 volts. It supports canopy sync, but it has negative to ground, so pay attention on it. Another way to power your devices, the newer devices, is Cambium CMM5. If you need Cambium, of course, devices like Medusa or 450i, you need another kind of Cambium Sync method. As I told you, the Cambium Sync, and they work at 48 volts. So another way to power your devices. Much more, if you have other kind of devices like MikroTik or Ubiquiti or whatever you want, microwave, you can power it through PoE, simple PoE system like passive PoE or a PoE switch, high power PoE switch. But high power in PoE switching means at least or maximum 500 watts, and this power is shared to all the ports, so you don't know which port need more power or less. It's difficult to predict. And of course, also these kind of devices generally negative to ground reference. So is it possible to have this kind of installation scenario? Of course it is. It's a typical installation. We have the router. I put a MikroTik just because I like it. We have Cambium devices. We have high power PoE switches, DC-DC converters, different power sources. Then we need surge protectors at the end to power 450 Cambium, to power Medusa, to power our other PoE devices in 48 volts or 29, or okay, this is the scenario. And the typical problems is low efficiency, because you have a lot of conversion, voltage conversion, 48 to 24, up to 38 again. The positive to negative, the positive and negative to ground is a big problem, and a big problem to solve. And if you use power switches, you have high power only on few ports, not on all the ports, so the power is limited. And how to manage this problem? Adding another switch maybe. And most of all, we have a lot of management systems. Difference between them, not just one dashboard to see everything you need, and it's very difficult to manage and to understand. Well, I would like to show you another scenario made by the 9.GigaSync. Is another way to see and to imagine PoE installation. Of course, it supports Cambium Sync. It's made for the Cambium Sync, of course, but you can use it to power every kind of device in your installation in your network. This is the installation with GigaSync. It's very different, you know. Comparing with the other one I show you. Here we have 3 cartridges on the front. You can choose whatever you want. Every kind of power source can be applied on the rear. So 29, 57, 54, minus 48, it doesn't matter. What you put in the rear, you will have in the front. So you need to power Cambium with 29 volts PoE, you can. You need to power Cambium Medusa with the same device, you can. You need to power non-PoE devices, such as routers or whatever you want, you can. You can power whatever you want with every kind of port mapping, and every port is very, very high power. So let the router make routing and put a PoE injection system to make everything else. GigaSync is only one power device. You just need one power device, a full managed system to PoE that make very easy the installation. It's very reliable. It's just one device, very robust. It's made by iron. Short circuit and surge protection on every port. One management system, just one management system to all your devices. 3 isolated inputs on the rear, and the ground is floating on each input. So no matter if you put plus to ground or minus to ground, very no problem on the GigaSync. And every port is high power, up to 3 ampere each port. 3 ampere, it's a lot of power, up to 150 watts each port, 12 ports maximum. You can monitor every port, monitor every tension, every load, shut down every port, make a power cycle. It's protected against the short circuit. Then later I will show you how it works. Okay. How is composed the GigaSync? We have the base unit without cartridge. The base unit can handle up to 3 cartridge. It's hot swappable cartridge, so you can put on and away in hot swap. The cartridge can be different cartridge, of course, PoE or terminal. The main unit has its own management systems inside, and it's very very reliable. And we have 2 different CPUs. One is used for the graphic user interface, so it's facing to you, and the other CPU is involved in the hardware stuffs, so short circuit synchronization and so on. So no ingestion between these 2 CPUs. And of course, you can make a software update of the base unit without shutting down your devices connected. Also, the synchronization is still there while you are rebooting, for example, the unit. No problem to your devices. They are still there working. So the base unit has the command unit included inside, and 3 cartridge slots. In the rear, we have the GPS antenna. The GPS is inside, or we can use the sync in and sync out ports to import sync in from other devices, such as another GigaSync, for example, or UGPS, Cambium UGPS. We have, of course, the Ethernet port to manage the system. And as you can see, we have 3 power connectors, 3 groups of power connectors for each cartridge. It's redundant, so 2 power connectors for each cartridge. And we have a little LED there that show you if the power is present or not. It's very useful because you don't need to open your web interface or your management interface to see if there is power or not. Just see the LED. And the main power to the unit can be given with the main power connectors, redundant, and through PoE. Also, the GigaSync is PoE powerable. So summarizing, GigaSync is low profile, is funless, no need to have fun inside the GigaSync. It's multi-input and multi-outputs. You can have a lot of power sources and a lot of power devices connected to the same unit. It has the GPS inside. It supports sync in and sync out. You have a full complex way of monitoring your systems. Every parameter in your installation tower can be monitored remotely, and you have full remote control on each port and each parameter of the unit. We have the PoE cartridge, and on the side of the PoE cartridge, we have the key connector. I told you that if you have to power different kind of devices, you need a different kind of PoE mapping, A, B, A plus B, and so on. I told you. Well, if you want to power a device or a B device or A plus B, you only need to put a little key on the slot on the connector of the 9-dot key. It's a little key. You put it inside, and the port will be powered with the right configuration. No need to put jumpers or dip switches. No, we don't want to use jumpers. Absolutely, it's very it can be a very big problem to use jumper if you miss something. Okay, just a little key and wow, super easy configuration of the port. We have an RGB code indicator in the front. Is a LED that tell you a lot of things of the unit just with one LED, and 4 high power PoE ports on the front. So for the PoE cartridge, it's of course Gigabit, use 9-dot keys, high power protection, and Canopy and Cambium Sync, both on the same cartridge. Then we have the terminal cartridge. Of course, also this one is 4 high power connectors with terminal block, bipolar terminal block, and the RGB code indicator on the front, the same. Bipolar, consumption monitor, which is the load applied to the port. You will know. High protection, I will show you, and high power. And a very, very easy to use web interface. We have a web interface. We have, of course, SNMP, reading and writing, and an API. You can build up your own software and send command to the unit or read parameters to the unit. It's very, very easy, very, very easy. If you just need to power a few devices, up to 2, we have also the light sync. Light sync is not manageable remotely, but it offers the same combination about protection, about high power. It has Cambium Sync, and it has the GPS inside and the sync-in port. So if, for example, you need to power 2 Medusa, well, here we have the light sync, just 2 Medusa to power, syncing through a GPS with just an injector, a small injector with a key map configuration on the front. Okay, this is the light sync. It's half rack unit, and you can combine with another one or with the compensation bar like this. Well, I'm very happy to show you this product, and now I would like to show you this product working. So let me show you something. Well, just a moment. Wow. Here we are. So this is the web interface of the GigaSync, and this is the GigaSync working. Oh, this is my iPad, so I can show you something. This is the GigaSync working. As you can see, here we have the main unit with a Cambium 450i connected, just to show you the sync pulse. We have the cartridge. Wait, I have some questions here. So, of course, you can ask a question. I prefer to show you the system a few minutes, and then I let you make me question and write it, please. So just few minutes, I show you, and then I will answer your question. As I told you, this is the GigaSync, and the cartridge are like, as I tell you, is hot swappable. In the web interface, you can see now the cartridge is removed by the system. Then I can put it on again, and it's okay. Now it's present. I can switch on and off some devices. For example, I can use the first port, as I can I can make a power cycle, for example, of the first port. As you can see, the port is now shutting down. The unit is disconnected, and then it's connected again. I can, of course, shut down the port. I can monitor every parameters in terms of temperature, voltages, and let's talk about synchronization, for example. Here we have the information, the main information. As you can see, we have the GPS connected, 10 SATs revealed, and we also have in the sync menu the possibility to have GPS synchronization. It's green, it means it have the sync pulse connected, or the sync in port now is disconnected, but I can show it, I can use it the same. I can set up, of course, the network. I have a small Wi-Fi interfaces on the GigaSync, so you can connect directly to with your device to the GigaSync itself without needing the need to put another cable, for example. Okay, and let's enable. Let's enable, for example, the synchronization for this unit. This unit can handle both Canopy Sync and Cambium Sync. So let's try to put the Canopy Sync on it. Okay, you see the Canopy Sync is on the port. The port is now chime. Canopy Sync is the port, and I can show it's receiving the Canopy, it's receiving the Canopy Sync. The Cambium is receiving the Canopy Sync as you can see here. And if I enable another kind of synchronization method like Cambium Sync, for example, no, sync, Cambium Sync. Okay, now we have the Cambium Sync connected. And Cambium Sync is on the device. So two methods of syncing in the same cartridge, very easy to select, just select what you want, and you have the monitor show you the power consumption. Of course, the radio is down. You can unpower your device. As you can see, you can power it. And let me show you something. What happened in your installation is if you connected this kind of connector. You can see it. It's a short circuit. Okay, let's do it. Boom, no problem. The port now is on error, as you can see in the web interface. It's a problem of short circuit, but if the problem is solved, for example, because there's some water on the cable, and the problem will solve in a few minutes, the power come back to the port after few seconds, and you solve the problem. It's very easy, very, very easy. Okay, and this is the light sync. Here we have, it's smaller, of course. We have the GPS connector, the sync in port, two power connectors on the front, and the keys. As I can show you here, we have these keys, and I told you that you can use these keys to determine which kind of PoE you need. It's a little key. You can put it here, connect to the unit, and on the web interface, you can see which kind of power system you are using. A plus B, B. In the other cartridge, we have the 9.sync key is the A plus B reverse polarity, and so on. A lot of kind of different port mapping. Well, here I am. If you have some question, I would like to answer. About Cambium APM P3000 Medusa, bot connected with the fiber and copper cable to power them. Can I synchronize with copper while data go via fiber? Yes, you can. The PoE can power the Medusa and give synchronization to the Medusa, and you can use the fiber to send data. Yes, of course you can. Okay. Do you have some more questions about this product? Do you like it? Okay. So if you want to verify prices and have quotation about this product, you can ask your distributors. They have all the stocks and price list. If you have any other question, please feel free to contact me as when you want. We have another question. On tower with a lot of FM can be problem to sync in copper. Well, the synchronization is very strong. The method is very strong. It depends on Cambium, of course, not on 9-dot, but this kind of synchronization is not like a negotiation of the port. That way can be difficult, but this kind of synchronization, especially Cambium synchronization, is very strong. I don't know, I never know about problems with FM. In Italy, we have our bigger WISP, it's EOLO, maybe you know it, a lot of installation. They install so far up to 3,000, more than 3,000 GigaSync on their installation. They are very happy about it, and they install all over Italy, and they never had problem with FM. Well, they never had problem with GigaSync itself, but not with FM. Okay. Are we going to share the recording session of the presentation? Of course. You will find it on our YouTube channel, and we can share with you the link. I really hope you enjoy this webinar, this presentation. If you have any other question, feel free to contact me. As I told you, no other question on it, so have a good day, and thank you very much to listen carefully to my presentation. Thank you, bye. Thank you to all.